Time feels constant, 1 second after another, always moving forward. But that's only true here, on Earth, moving slowly through space. Out there, time behaves very differently. If you travel fast enough, time slows down. If you're near something massive enough, time bends, not metaphorically, literally. This isn't science fiction. It's measurable. It's already happening. Right now, clocks in space tick at a different rate than clocks on Earth. If we ignored that fact, our technology would fail within hours. What's strange is this: time doesn't exist on its own. Space doesn't either. They are not separate things. They are part of a single structure, one fabric that can stretch, bend, and distort. The faster you move through space, the slower you move through time. The stronger the gravity, the more time resists motion. That means time is not universal. It depends on where you are and how you move. And once you understand that, the universe looks very different. When we think about gravity, we usually imagine a force that pulls things downward. An apple falls. A planet orbits a star. Simple. But that picture is incomplete. Gravity isn't just a pull. It's a distortion. According to our best understanding of physics, massive objects don't merely exist in space, they change space. And when space changes, time has no choice but to change with it. Imagine space and time as a single fabric, not two things. One, structure. When you place something massive into that fabric, a planet, a star, a black hole, it creates a curvature. Space bends, and time bends along with it. The stronger the gravity, the deeper the bend. This has a very real consequence. Time moves more slowly in stronger gravity. A clock on the surface of Earth ticks slightly slower than a clock in orbit. A clock near a neutron star would slow dramatically. Near a black hole, time nearly comes to a stop relative to the rest of the universe. This isn't theoretical, we've measured it. Atomic clocks confirm it. GPS satellites must correct for it constantly. If gravity only affected space, time would remain universal, but it doesn't. Gravity reshapes the entire space-time structure. That's why planets follow curved paths. That's why light itself bends near massive objects. And that's why time is never the same everywhere. There is no master clock for the universe. Every location has its own version of time, shaped by the gravity it experiences. So when we say time and space are linked, this is what we mean. You cannot bend one without bending the other. Gravity proves that time is not a background process ticking away independently. It is part of the geometry of the universe itself. And once you accept that, you're no longer living in a universe with space and time. You're living inside space-time. Gravity is only part of the story. Even in empty space, far from stars or planets, time still isn't fixed. It depends on how fast you're moving. This is where intuition breaks down. You might think motion only changes where you are in space, but at high speeds, motion changes how fast time itself passes. As you move faster through space, you move more slowly through time. This isn't an illusion. It's not a trick of perception. It's a fundamental property of reality. The speed of light is the key. It's not just a limit on motion, it's a constraint on space and time together. No matter how fast you travel, the total rate at which you move through space-time remains constant. So when more of that motion is used to move through space, less is available to move through time. The result is time dilation. A clock on a fast-moving spacecraft will tick more slowly than a clock at rest. Particles moving near the speed of light decay more slowly than they should. This has been tested repeatedly, and the results are precise. At everyday speeds, the effect is tiny. You don't notice it driving a car or flying in a plane, but at extreme velocities, it becomes dominant. If you could travel close to the speed of light and return, you would find that far less time had passed for you than for everyone else. The universe would have aged while you barely had. This tells us something profound. Time is not universal. It is not absolute. It is tied directly to motion through space. Space and time trade with each other. You cannot change one without affecting the other. So gravity bends time by mass. Motion bends time by speed. Together, they reveal the same truth. Time and space are inseparable aspects of a single system. And the faster you move through the universe, the less of it you experience. Once you understand that gravity bends space-time and motion alters time, the larger structure of the universe becomes clear. The universe is not made of objects moving through an empty backdrop. The backdrop itself is dynamic. Space-time is the framework that determines how matter moves, how galaxies form, and how the universe evolves. Matter curves space-time, and that curvature guides the motion of matter. This interaction shapes everything we observe. Galaxies are not randomly scattered. They form along regions where space-time is curved by large amounts of mass, creating vast filaments separated by enormous voids. The universe naturally develops a web-like structure because space-time responds to matter and energy everywhere. Light follows these curves as well. As it travels across the universe, it bends around massive objects and stretches as space expands. When we observe distant galaxies, we are seeing both their light and the history of space-time itself. Even the expansion of the universe is a space-time effect. Space is not expanding into something else. The distances within space-time are increasing over time. There is no universal clock, no fixed reference frame, no absolute present moment. Everything, from galaxy clusters to cosmic expansion, is shaped by space-time. Time and space are linked because they are not separate elements of reality. Together, they form the structure of the universe.